Hello. There's not usually like people in my room. Yeah, it's a little messed. Don't mind. Uh, there actually have never been people in my room before. I don't know. They just say I'm lame and boring. Maybe it's just them who's boring. I don't know. I don't know. But um, I have so much to tell you. Like so much interesting stuff. Did you know that in Latin there are names for every substance in medicine? And I know people think that it's like a dead language that's not used anymore anywhere, but it is used daily everywhere in the world in medicine, and it's really cool that people all over the world can understand themselves, each other, by talking like in a dead language. And I realized it just now when I wanted to say that I took a pill of a painkiller, and I didn't know the word for it in English, only in Russian, and I couldn't wrap my head around on how to um, say that. But then I remembered that there's Latin for everything, and I was just so happy. But I forgot the name in Latin already, so I unfortunately will not tell you. um, but there's so much cool stuff about Latin in medicine, because there's names for every anatomical structure ever, and they often connect. So, for example, the name for the tibia bone is Latin. It's actually like a Latin term, and okay, the bone is called tibia, and there are things that go in the same direction as the bone, and they are called tibialis. So if there's an artery that goes the same direction, it's arteria tibialis, and if there is a nerve that it is going the same direction, it like powers the bone. I don't know how to say that. It's called nervous tibialis, I think. I don't know. Let me check. Sorry. I need this. But I don't know where the nerves are in this book, so this is going to take a lot of time. Okay, I'm sorry. Just really want to know if I'm bullshitting you right now. I need to check this. Okay, there we go. Yeah, there it is. There it is. Nervous tibialis. I was right. I'm always right on stuff like that. Anyways, I think I told everything there was to say about Latin, but there's so much more cool shit about medicine that I'm really passionate about. There are also I love genetics. I fucking love genetics. It's such an interesting field, and just the just the ways that an organism can change, which is related to genetics. The amount of the ways that this can happen in is just absolutely bonkers, because the changes, they can be genetic and not genetic, and the non-genetic ways are let me just tell you about some terms to make it more understandable. So like a phenotype is like a composure of an organism's outside and inside qualities. So like hair color, eye color, maybe percentage of fat that the organism is prone to gaining. Like there are so many like characteristics, but also it's like wait, there's like the fluids that your body produces. It's also like coded by genetics. So, for example, there's this genetic disease that's called phenylketonuria. I think that's how you pronounce that in English. I don't know. But it's basically when your body, the metabolism, it just does not work properly, and people with that disease cannot like digest any proteins, and because of that, the proteins in their body, they like go through a chemical chain reaction, and it basically all fucks everything up. Their body produces this neurotoxin, and it basically kills their brain if you give them enough proteins. So that's really interesting. But basically that's how genotype affects phenotype. So that's an example of that. So phenotype is like a combination of your outside characteristics, your metabolism characteristics, and all that. So it's basically your physical form, and genotype is like the code of your genes that affects your phenotype. So your hair color, your natural hair color, okay, I'm pointing at myself like I don't look like this, and basically your hair is your phenotype, but your genotype is the code that codes your hair, if that makes sense. So as an example, like a game, okay, so the code of the game is the genotype, and the resulting game is the phenotype. So I think that makes a little more sense. And like again, there are so many ways that the phenotype can be affected like during your life that is not related to your genotype. Basically, there are like 3 ways in which it can be affected. It can be like wait, I need to consult with my notebook. I'm sorry. No, where is my genetics copybook? I don't know where it is. I think I gave it to my friend. Okay, no, it doesn't matter. There are like 3 ways in which a body can be affected, and it does not like pass on to your to the organism's offspring. So the first is like, for example, gaining weight, gaining muscles, or losing muscles due to like outside world outside factors, or like getting tanned, and the stretch of this of this form that a body can gain is still coded by genes. So like if you are for example, let's say Caucasian, and you get tan, your genes code for the range of this morphosis. So like you can, like, it's a spectrum, and you can be, for example, like only here and here. And if here was like a black person, you would not be able to get like as tanned as them, just because your genes code for this specific like range of it, like being, I don't know, of it being, okay? And again, that's tanned, getting fat, losing fat, all that. Also, your hair length is actually affected by your genes. So there are people who like very well cannot grow their hair like past their waist, just because their genes code for that length of hair, and they will just not grow past that length. Even if you will not cut it your whole life, it's just how it is. That's an example of the first variant. The second variant is like it's when the outside factors still affect an organism, but it's like it's harmful. So for example, like frostbite, losing like limbs to frostbite, for example, is an example of that change that affects phenotype, but it doesn't affect genotype, so there is no passing that thing to your offspring. And the third variant is called like phenocopies, and it's when something that is affected, that something that is created by outside factors in an organism, it like mimics something that can be produced via genetics. So for example, there are genetic cataracts, but there are also cataracts that are like the result of some trauma, or of a person like working in a hostile environment that just makes their eyes go bad. And that's an example of a phenocopy. And then like the most cool part about genetics, of course, is like the genetics itself. And like again, I'm a very big fan of medicine, you could have noticed. And there are so many cool illnesses and like syndromes and all that stuff that is coded by the genetics. And I particularly like sex-related genetic syndromes. So basically, in the human body, there are 46 chromosomes, and 44 are autosomes, which means that they code like the whole body. And there are two other chromosomes that code only sex, so XX chromosomes and XY chromosomes. And X chromosome is present in every single like human, no matter their sex, because it also codes for like very specific processes in the body. So it's like an essential chromosome, and you cannot live with it. And due to that, there is this really cool disorder, which is called not like a disorder, syndrome, which is called, or is it a disorder? I don't know. It's like Turner syndrome, which is when a person only has one X chromosome, and usually in chromosome-related disease, especially these like sex-related chromosomes, it usually is basically like vice versa. So there's the same diseases for like the same karyotypes. Karyotypes is like the amount of chromosomes that a body has. So there are the same what was the word? I just forgot it. The same karyotypes, both for female organisms and for male organisms, phenotypically. But in the case of Turner syndrome, there's only one way of like acquiring this syndrome, and it is by having only one X chromosome. So usually people have two chromosomes that code for sex, but people with Turner syndrome, they have only one chromosome. So in total they have 45 chromosomes, which is one less than an average person has, and and they are phenotypically all female, and they have a bunch of symptoms such as slow growth rate, mild like intellectual impairity, I think. Also, they have like folds that go from here to like their shoulders. I don't know what I don't remember what they're called. And some other symptoms, but they're also infertile, although I know there was like a case of a person with that syndrome being like in therapy and having like offspring, but that is not the case for like most of people with Turner syndrome. So if you have Turner syndrome, you will probably never have offspring, no matter like what your you'll have female no how do I say that? No matter how much you want it. Okay. Next syndrome. There's also like many syndromes that relate to autosomes. So the chromosomes that code for like everything that is going on in your body, and there are syndromes that relate to chromosomes being duplicated, triplicated. You can have like 3 chromosomes of the same pair, 4, 5, 6 even, which is very rare, but it can happen. And there are like many disorders of that kind, but like Down syndrome is probably the most famous, which can be actually like it has a lot of myth surrounding it. Specifically, I know that a lot of people think that all people with Down syndrome are stupid, but like not stupid, but like low intelligence, which is not true. Specifically for the reason in the way that Down syndrome actually occurs. So it can occur on the stage of the persons with the syndrome parents like sperm and eggs forming. In that case, they're like when they like collide. I don't know when. What's the word? When a zygote forms. When a zygote forms out of these sperm and eggs, every single cell in the resulting person's body will have like 3 chromosomes of the 21st pair, and they will have like the worst Down syndrome possible, because all of the symptoms will be like max level, and yeah, that's not good at all for the person, because again, max like bad symptoms is bad. But if they have, if their parents had like normal sperm and eggs, you may ask, like, how does Down syndrome occur in that case? And in that case, there is like when cells divide during embryonic development, there can happen like this glitch when chromosomes just don't go where they're supposed to go, and they end up in the same cell. So there happens to be more chromosomes than needed, and that's basically Down syndrome, but only chromosomes of the 21st pair. So it happens that they're only like in that particular cell that this occurred in, and the other cells are healthy, and that's called a mosaic. We are basically all mosaics, but when this happens on a late stage of embryonic development, it's not that noticeable. But when it happens in the early stage of embryonic development, it's very dangerous for development of these kind of syndromes, because then the percentage of the cells affected by this is much more than would be on the later stages of embryonic development. So the range of possible symptoms and the strength of these symptoms are related to the stage of embryonic development when this mosaic occurred. So basically, a person with a Down syndrome can be very, very affected with this syndrome, and can be affected less with this syndrome. So there are people with Down syndrome who can work like a normal job, who can live a normal life, who can like do certain tasks, although they still would be disabled, but they would be like basically like not affected with the syndrome. And I think that's really interesting, and especially important to know, because Down syndrome is so stigmatized, and knowing how different it can be is important. It is important. And also, it's like a very interesting fact that Down Syndrome Awareness Day is like on 21st of March, because the illness itself, the syndrome itself, is like 3 chromosomes of the 21st pair, and it's on 21st of the 3rd month, so I think that's just genius. And I really like that they picked this exact date. I think it's just incredible. And I think I have told everything that I wanted to tell you. I really hope you come back here. I really hope. Was I too much? No? Okay, I really hope, because I don't get a lot of friends at all. Yeah, they all say that it's not that interesting stuttering over genetics facts for minutes on end. Yeah. You wanna go? Okay, cool, I guess. Okay, bye.